Hi everyone, good morning. My name is Meredith Scott, Marketing and Communications Project Manager for Axtra 3D. Thank you so much for joining us this morning. We are very excited to host this webinar just to give you a little bit more insight into all that HPS has to offer. Both Gianni Zitelli, CEO, and Paul Spoliansky, CRO, will be speaking today. At the end of the webinar, you can expect a Q&A, so feel free to write your questions in the chat as they arise, and we will do our best to address all of them at the end. Thank you so much, and please enjoy this webinar.
Good morning, good morning, good morning. Thank you so much for joining us today. Today we will speak together with me and Paul about our new HPS hybrid photosynthesis technology, and as you will see during this webinar, about our completely new LED engine that we are today implementing in our Lumia X1 printer. I'm Gianni, founder and CEO of this company, and also together with my team, inventor of the entire portfolio of technologies and patents that today we are using on our printers just now on the market. Well, but extremely important today, we are not speaking about in general bottom-up or top-down technologies. We are not speaking about the pilling process, you know very well. So in bottom-up systems, for example, the continuous process or the stepping process or tilting and standard pilling technologies. What does it mean? The capacity to remove the just cured layer from the bottom of the vat. And we are not only, we are not speaking about top-down systems. Today we are describing how we are able to implement this completely new high-speed SLA technology using our completely new optical device, in this case the HPS, the hybrid photosynthesis LED engine, in stereolithography in general. So again, what you will see today is not the capacity to generate an entire layer, again with both bottom-up or top-down system, but the effect of our LED engine in additive manufacturing. To approach our new invention, let's start from the story of our technologies of stereolithography 3D printing technologies. Let's start with the very well-known SLA technologies. In this case, we are, as you know very well this video, we are speaking about a laser as light source able to cure the entire layer that we have to generate during the 3D printing process. Again, this video is well known. We are speaking about charcoal more than 20 years ago, at the end of the 19th century, when charcoal invented in 1984 the SLA technology. What does it mean? Using a vat of photopolymers and a laser to cure every single layer. Well, what is the meaning of the SLA technologies? Exactly like a pencil, we are using a laser to cure the entire layer. Which is the value of this technology adopted today? And an amazing technology that we can use the laser to generate the contour of the layer we want to generate. What does it mean? That we, like exactly like a pencil, we can draw the contour, obtaining what you will receive in your hands, not the surface of the 3D printing parts. But having only one LED source, you are also obliged to use the same pencil, the same laser, to hatch the cross-section of your parts. The effect is that you have to spend a lot of time to generate your layer. This is a pretty important example. So to cure this part, this cross-section, you are spending 0.21 seconds to generate the value, what you will have in your hands, what you will see. You are generating the surface of your printed parts, and you are spending more than 5 seconds simply to hatch the cross-section of your printed parts. Well, you know very well, roughly 10 years ago, this world, the 3D printing world, introduced a completely new LED source to cure the layer. In general, what we call today DLP printers. DLP is is a simple projector. What does it mean? That we are using this optical device to cure in one shot, only in one shot, the entire layer. Which is the value? First of all, a technology like this one, we can call them volume invariant. What does it mean? If you print only one part, or if you print in the same platform more than one object, of course the printing time will be the same. Again, simply because you're using only one flashing phase from the projector, or today also from an LCD technology, in one. Which is the problem? That in general, again, now the yellow line is what you want to obtain, but you are projecting pixels. So you are projecting a digital image. What does it mean? That the real effect that you will see in your hands is the pixelization of your surface. Of course, you can increase the resolution of your system, reducing the pixel size you are projecting, but from the other side, of course, you are also reducing the final building area. Today we're seeing adoption of new projectors, 4K pixel shift projectors, or real 4K projectors, maybe tomorrow 8K projectors, but in any case this is a compromise that we have to accept. From one side, in general, we have SLA technologies, a laser-based technology with an incredible resolution, with an amazing surface quality and part finishing. Also, the junction points using those technologies are extremely thin, simply because you can use a laser and the spot size of the laser is so small to generate the layers. But of course, those technologies are extremely low. From the other side, DLP and or LCD technologies, extremely fast. So the productivity in this case is absolutely 10, 20, 30 times higher than a standard SLA technology, with the disadvantage that the resolution and the surface finishing and the part quality are absolutely lower than what you can obtain with an SLA technology. And of course, another point, you have to also accept a compromise in terms of building area. Again, increasing the building area, you are simply losing resolution because the pixel you are projecting is simply bigger. Well, a couple of years ago, in 2021, we introduced a completely new light source, what we are today calling HPS technology, hybrid photosynthesis technology, and our LED engine. And this is the effect on 3D printing. So this is for sure the most important slide that today we will share together. On the left side of your screen, you are seeing an SLA technology. What does it mean? Between two monitors, you will see exactly and simply the layer that we want to cure with, on the left, a standard laser, and on the right side, you will see with our new HPS technology. So let's start to curing again absolutely the same layer using, in this case we are simulating a really common resin on the market. So we are speaking about roughly, in a standard DLP technology, roughly 3.5 3.8 seconds for curing time. And you are seeing on the left side right now the scanner, the laser, curing, having of course the same effect on the polymerization, curing the layer, or at least an entire platform of objects that we want to print. So as you can see, we are simply waiting. but the curing process, and again, only the curing process is extremely slow, simply because we are using the laser not only for the contour, but also to hatch cross-section of our parts. Now, again, on the right side, in a few seconds, you will see our new LED engine in action. Again, curing the same layer, simulating the same resin. So we are speaking about roughly 80 seconds for a standard SLA technology, and as you can see, following the curing time of this resin with a DLP projector, 3.6 seconds with our new HPS technology. That's the reason why we call this evolution of our work the end of trade-offs. Why? Because again, in general, with an SLA technology, with a laser, you can achieve an amazing quality, but the productivity of your device will be extremely low. From the other side, the LP, absolutely fast, the fastest today printers on the market, but the resolution a low resolution devices. Well, today with our HPS LED engine and our new high-speed SLA technology, we are combining both the advantages, the highest quality, and you will see why the highest quality, better than an SLA technology, with the same throughput of a DLP system. Well, now let's start entering in the description of our LED engine, of our optical device, and that's the reason why we're calling why, not how, our LED engine works. In general, the idea to combine two light sources, obtaining both the advantages, is not so new. For at least 10 years, a lot of inventors try to combine both the light sources using two different strategies. The first one is this one. So what does it mean? That you can use the first light source, for example, a projector, to cure the cross-section in one shot. And after that, using the second light source to cure the contours, a laser in this case, to cure the contours and obtain the best surface quality. In general, this technology doesn't work because, for two reasons. In general, because of course you can't create the right crosslink, curing the contour and the cross-section in two different moments. You can obtain the right crosslink, chemical crosslink between the contour and the cross-section. And also the complexity in there, for example, using a mirror to combine with 45 degrees to combine both the light sources with resolutions under 20 microns is a real challenge. So also the mechanical complexity is a real challenge. Well, another technology that you can find today, at least as publication, university publication, is the idea to combine with a dichroic mirror two light sources, a DLP, also in this case a DLP and a laser, together using different wavelengths. Well, also this technology, pretty promising, is a real challenge because you are using, in this case, for example, 355 nanometers from the laser and 445, so in the visible band, from the DLP. What does it mean? That all the materials that you have to develop have to work with two initiators, and the complexity is so high that put on the market materials with different initiators inside, obtaining the results in terms of X, Y, and Z accuracy and mechanical performances today are not enough. That's the reason why also in this case with the adoption of two different wavelengths is not a light engine on the market. Well, let's start describing how our technology works. This is a slow motion technology. As you can see, better than PER. As you can see, we are delivering in a real coaxial system both the light sources simultaneously with the same wavelength. As you can see here, now also the color. In this case, this LED engine is developed at 4 or 5 nanometers, simply because this is one of the most extended portfolio materials today on the market. But what you are seeing here is the HPS technology in action. So we are delivering simultaneously at the interface in a real coaxial system without, this is extremely important, without mechanical components, motion on mechanical components. We are able to deliver both the light sources at the interface using a very specific behavior of the light. In our case, is very well known today, and I'm so happy to say that today our patent is a granted patent. We are using the polarization of the light to obtain what we are calling HPS technology. What does it mean? That again, using a very specific behavior of the light, we are able to deliver at the interface the polymerization under the VAT in this case, but it's extremely clear that our technology and our light engine can be used for both top-down and bottom-up systems with different wavelengths, with different building areas. We are implementing a real coaxial system with our components are completely fixed, and that's the reason why we are able to combine both the sources with a resolution under 20 microns. But which is the effect in the real world? First of all, quality. Well, this is another trade-off now that the old technologies have to accept. Well, in general, when you design an SLA printer, you have to define also a sort of compromise between the resolution you want to achieve, but also the minimal feature you want to achieve, and the spot size of your laser, simply because if the spot size is so thin, you will spend a lot of time for the etching phase, no? So in this case, you are obliged to find the right balance between productivity and resolution. In our case, the approach is completely different. That's the reason why today on Lumia X1 we are using a 50 microns laser spot size. Why? Because we are using the laser only to generate the contours. In general, 1, 2, 3. In the worst case, 4 contours with the laser, because we are simply curing the cross-section using a DLP projector. So for us, the resolution of a projector theoretically is not a doesn't mean the resolution of our system, because the resolution of our system is related to the spot size of our light engine. On Lumia X1, in this case, 55 microns. But also resolution. Well, it's not only a matter of surface quality, it's also a matter of resolution. So when you say, when you listen on the market, well, but I can use, for example, an anti-aliasing system, on my DLP or LCD system to compensate the pixelization of the surface. Yes, it's true, but using a technology like this one, a software like this one, you are introducing noise. This is an extremely interesting result. This is a comparison between our light engine only with the DLP on the left side, so we are speaking about a 4K projector, 2K plus 2K pixel shift with 65 microns resolution, 69 microns resolution, and from the other side, the same projector, also enabling our laser HPS technology, so delivering at the interface both the DLP and the laser. And this is the resolution. You can easily see the laser on the right side, the laser running all around the contours, reason why we are able to generate now numbers 1, 2, 3, 4. We are speaking about, for the entire string of numbers, we are speaking about 2 millimeters, so is extremely, and the thickness of every single number is 200 microns. It's also a matter of surface quality. This is another application. This is printed in one shot. This is one of the nozzles we are using to show the difference between the HPS and a standard DLP technology. Also in this case, this part is printed with our Lumia X1, which is the difference. We are, for the first part of the object, we are enabling the HPS technology, so we are printing with both a projector and a laser. And of course, in a certain moment, we are turning off the laser, obtaining is extremely clear. And again, in this case, we are speaking about 65 microns resolution, the pixelization of the surface with a DLP. But of course, the Curing time remains absolutely the same for every single layer in both HPS mode and DLP mode. It's also a matter of accuracy. You know very well that with DLP systems, you are delivering also distortion of the projected image. Well, also in this case, using the HPS is not a problem simply because the accuracy of our system is related to the accuracy of our calibration mask from the laser. So in this case, as you can see, we are speaking about 25 microns rotundity, but also plus minus roughly 21 up to, in the worst case, 50 microns accuracy for the entire platform. Again, simply because we are using our calibration mask to obtain the best accuracy from our laser and matching using a very specific slicer fully developed in-house, combining the cross-section using the image projected by the second optical device. That's all from the technical development. Thank you so much and see you in a few minutes. Now that we will start speaking about Lumia X1, our printer that are implementing together with Paul, we are implementing the HPS technology. Thank you so much again.
Hey, I just want to give Gianni a big thank you for the technical explanation. Certainly, hybrid photosynthesis is being a new technology allows for not a lot of new possibilities in additive manufacturing. I'm excited also to introduce myself. My name is Paul Spoliansky. I'm the Chief Revenue Officer at Extra 3D, and I'm also excited to share a little bit about our product. So how do we create the perfect home for our HPS light engine? I'd like to introduce the Lumia X1. So as you can see, this is a product that's been designed in the U.S. and is currently being manufactured in Italy. It certainly has that Italian style to it, as you can see. But more than style, it also has a real focus on functionality. We intend this printer to live on your production floor, in your RP lab, for 10 plus years to come, pumping out amazing prototypes, tooling, end use parts, and we've really outfitted this machine with an industrial build. So everything you'd expect from a machine tool is actually on this machine. So emergency stop button, as you can see, we're using a large LED graphic user interface to make operating the machine from the front of it very easy and intuitive for our users. Obviously, as something as trivial as a USB port for moving files in and out of the machine, depending on your network restrictions, is a nice feature as well. One of the key features we have here is that we have swappable platforms. You can be online or offline. So for all you aerospace companies, medical companies, consumer goods companies that have extremely high protection on your intellectual property, you can operate 100% offline and be 100% assured that you're not sharing any information that you don't want to share. So obviously, the Lumia X1 is the first machine to come to market with high-speed SLA technology or hybrid photosynthesis. So we're extremely excited to debut this technology in the U.S. and in Western Europe. Moving on, talking a little bit about some other features. Keeping in line with the industrial theme, we decided to implement a double Z-axis. This allows the printer to manage a wide range of materials, including high viscosity materials, filled materials. It also makes the printer a lot more robust than a single axis system, since you can manage forces that may be asymmetric under the platform during a print process. So this is a key feature of the product, and one of the things that leads to increased reliability and printability. As you can see from this diagram, also we have integrated chamber ventilation. This is just going to be a safety concern. We want to make sure that we don't know every material that our customers are going to be running. Some materials can be more toxic than others, so we wanted to outfit the machine in a way that it's kind of future proofed and can be used for more exotic chemistries that may have more of a risk. So you can go ahead and hook this up to an active ventilation system, or even something like a HEPA filter um, for internal use. Obviously, this is a class 1 laser device as well, so we've implemented a magnetic interlock safety system. Again, user safety is one of our primary concerns, and you can see that implemented here in the design of the machine. Also, I'm not sure if you can tell from this render, but every surface you're seeing here, all the black surfaces are all anodized black aluminum. We're using 5000 series aluminum for all of the doors and non-structural elements of the printer. And then we're using 7000 series anodized aluminum for all the structural parts of the printer. So this is not a low-cost printer. This is really a work of art, and it's been designed to be a production piece of equipment that lasts, like I said before, 10 plus years. Another kind of creature comfort is our LED color status bar on top. It's a little hard to see in this slide, but this can tell you what the printer is doing from across the room, right? So you don't need to go and check on it on your phone. You can look across the room and say, hey, is my printer active? Is it printing right now? In which case it would be green. Is it on standby? In which case the LED bar would be white. So this is a nice feature as well that you'd come to expect from industrial equipment, right? So as you can see, also one of the things we did is we wanted to let users know where they're intended to interact with the machine. So all of the red anodization indicates as a user touch points. And one thing we also changed here, which is a little bit different than a lot of the folks in the industry, is we wanted to have a printer that provided excellent privacy for customers that aren't interested in letting passersby see what they're printing. So we used a rather small incognito viewing window. What's cool about this is when the machine's closed, you literally can't see a window at all. It looks totally opaque. But if you turn the chamber light on, suddenly you can see exactly what's going on in the printer. So for the user that knows the printer, they can easily see what's going on, but it's not so easy for other people to see, which is a benefit. We've also integrated a 4K camera in the chamber. Among other things, it's used for being able to see what's happening with the printer. But you can also we're also using it to program AI features so that the printer knows if there's a build hanging from that platform at the moment, prevent you from starting a new build. And we have a whole body of work that we're using this camera for to make the printer smarter and continue and have continuous improvements. One of the last things, but probably one of the bigger deals on this slide is our IntelliCartridge material handling system. This product is not available today. We're in the beta testing phase, but this is essentially the first integrated material handling system. This is not used to lock down the machine. It's simply used to make the user's life easy, right? So as you can see on the left, we have a peristaltic pump. On the right, another one. The left one is used for filling the vat, so you can have an extra 5 kgs of material in this IntelliCartridge vessel that the machine can control. So once that IntelliCartridge is sitting in position, it hooks up to a stepper motor, which is turning an auger inside the cartridge, which is allowing for active stirring. And again, this is all programmable from your machine. So you can say, hey, I want this to spin 25 times per hour. You can program anything you need for that specific material or application. You can also adjust the pump times based on material viscosity. We're also planning to introduce infrared heating capabilities to keep the whole 5 kg vessel above room temp, and so you can start manipulating viscosity of the resin as well. Lastly, when you're done with your build, instead of removing the whole vat and straining everything, you'll have the option to use the suction portion of the IntelliCartridge system, which allows you to suck up all the unused resin and run it through an inline filter and put it back into the IntelliCartridge. Now you're ready to start your next build. You simply cycle it back on and you start filling your vat again. So this is a really exciting kind of development, and we think it'll allow, especially where a customer is printing the same material over and over again in a production type format. We think this is going to save a lot of time and add a lot of convenience. I'm putting together a quick little video here of the user operation just to show. This is Gioia from our team in Vicenza, Italy, and she's just demonstrating how you lock the vat in place. Also, this is how you open the bridge, so you can put the platform in and simply just put the lever up to lock it in. Pull it down when you're done with your build, and voila. Very easy operation. I mean, honestly, one of the things that I saw when I saw this machine the first time, I was really impressed with how easy the user operation is. It's really designed to just be very simple to operate. All right, moving on. No printer is complete without a slicer and software, so I'd like to introduce you to our volume software. So in general, this software is an extremely capable software, which allows all the main functions you'd expect from a print driver. So you can bring different types of files in, orient them. By the way, we're also working with some strategic partners on the software side. So let's say you have eStage. If you wanted to use supports in eStage and then bring the whole file in here, that's absolutely fine. You can do that. We also have our own supportation options within the software. So here those are. We have automatic supportation, which is pretty advanced. Sometimes it'll over support a little bit, so you need to be kind of fluent in making adjustments to the supports. Obviously, you can make copies when supports are done. You can build out a whole platform and finalize your orientation. There's also manual support options. I'll just mention. There's different types of support structures that you can use and manipulate. So it's got a lot of functionality that we think customers will really appreciate. Lastly, we can go ahead and slice our files and send them to the printer. While this is doing this, I'll just point out, since our light engine is so unique, combining the SLA and the image generator, our slicer is unique as well, because we have to manage both of those two different light engines, right, on every layer. So the file that we're producing here is proprietary and unlike anything else on the market today, which is really exciting. So moving forward, we've gone ahead and sliced our files. Now we're going to go ahead and select the printer and send it to the printer via our software bridge, which is what you're seeing now on the screen. And once that's done, we simply go to print. So one of the most important things about 3D printing is materials, right? And there's a couple complexities with it, in my opinion. There are some companies that have closed models that every single material they offer is from them. They've made it themselves. They're controlling the parameters. They don't let customers control the parameters at all. And then there's also some hybrids. There's some out there that will charge you a fee to have an open material license, or to have further control over parameters. And that fee can be in the range of $10,000 to $20,000. At Axtra, we really believe when you buy a printer from us, you should have full control. So I just want to point out, we're open from a materials perspective. So when you buy this printer, you within our volume software, you have full access to every single setting, and you're allowed to run any material you like and do that independently of Axtra 3D. We've also spent a fair amount of resources and time developing what we feel are best in class build parameters for useful materials. And so if you'd like to use those, you're obviously welcome to use those as well. One of those materials is our Extra 3D draft gray material. This material is incredibly fast building. The print speed is very fast, as you can see on the right here. We were able to print 2,980 layers in 9 hours. This is also a good example of our print technology. We're able to handle big cross sections. We've actually even printed solid blocks in the past, just to test, to torture test the system to see what it's capable of. And I'm not going to get too much into the layering technology on this webinar, but we have a very wide process window. We can handle all the different geometries, which is really quite nice. We also don't require like redesign, right? So if you have a part that was designed for injection molding, we can find a way to print it without redesigning it, which is quite nice as well. This material isn't really impressive from a mechanical perspective. It sits there with an HGT of 25, tensile strength of 39 megapascals, pretty low elongation at 4%. But the reason we love this material is because it's incredibly accurate. The surface quality is sits next to none, and ultimately, for concept modeling and draft prints, this is a great material just to get the maximum value out of our light engine technology. Just another quick example of the extra draft gray resin printing some dice. Thank you Materialize 3matic for helping us make these dice. That was a great little giveaway part that we did at a seminar, and we gave those away to all the attendees. So it was really cool. We were able to print 32 dice in 26 minutes, sitting on supports. So just to give you an idea of the printer speed, it's pretty fast. We're also really fortunate to be partnered with Henkel Loctite. They have a nice material portfolio. This material has gotten a lot of attention in the market, and so 3843 is a really tough, high impact, semi-flexible functional material, great for functional testing. Also just has a really beautiful surface quality to it. Obviously, HGT is at 63, so it's got decent heat deflection. Tensile strength is at 51, decent strength. 43% elongation at break, which makes it a really interesting material for functional testing, and just super durable, right? Another material from Henkel that we're working with is the IND 405 clear material. From a property perspective, it's pretty impressive with a 53 HGT and 101% elongation at break. So this is another material we're interested in. It also has very good clarity right off the printer. Another partnership we're incredibly proud of and excited to further to explore further is the 3D Systems partnership. I believe we're one of the very few companies that 3D Systems has extended this offer to. So again, incredibly grateful to be working with the pioneer in the 3D printing space. And we're starting off with a Figure 4 tough clear material, which is really an amazing material. I mean, absolutely could be used for end-use parts as long as it's internal. Has a nice long life, can handle some UV exposure, but ultimately giving you that nice kind of round distribution of properties with about a 50 HGT and 13.1% elongation. And one thing we're really impressed with too is the resolution of this material. The shrinkage is extremely manageable, so we're able to print extremely high resolution and extremely accurate parts. On the 3D Systems note, we plan on adding quite a few more materials from their Figure 4 line. Next up, we have their Figure 4 AMB 300, which is a high temp material. Pro Black 10 is coming up as well. And many more. So really excited to see this relationship with 3D Systems grow and start getting some of these amazing materials out in the market on our Extra 3D Lumia X1. Seems like we're working with a lot of amazing material providers. I mean, BASF, obviously they have a huge name. I think maybe they're one of the largest on the planet. And they came to market with this really interesting material called 3280, and it's a ceramic filled material and with a very high HGT, very high modulus. And so we're looking at some really interesting applications here where we're looking at injection mold tooling, inserts, also blow mold tooling, carbon fiber layup tooling. This could be used for wind tunnel models as long as it fits in our build area, which is pretty big. It's 9.8 by 5.5 inches by 20. So we think this could be a really interesting material. Also, the cost of this material is considerably lower than competing materials in the market. And we're absolutely blown away with the performance. We're only like the exposure time on this material is less than 1 second, so it's an incredibly fast building material, and the accuracy we're seeing is sub 30 micron across the build platform. So super excited to see the new applications that we get to address with this new material. So if you've ever been looking at injection molding and been disappointed with results from different technologies, I highly encourage you to check this out. Just to make sure we get the best from all the best, we also have a partnership with Evonik. And they're a new player in the additive space, but we've been incredibly impressed with their formulation. So this one in particular, the Infinom ST6100L, is an amazing material. It's got a high HGT of 120C, still with some elongation, so 6.5% elongation, pretty high modulus. And this is a material that we're exploring for connectors and other industrial applications, industrial housings. I mean, this is a material that's been designed for niche parts to be used as end use applications. So it all depends on your application and what your requirements are, but this is a potential fit for end use applications. And we're, again, super impressed with the print speed and the mechanical properties, and excited to grow our partnership with Evonik as well. We're also dabbling a little bit in jewelry, because our light engine has such high accuracy, and this is a material that we had partnered with. This is actually kind of a friend of the company that we started playing around with, and we were just really excited. We've been able to print this at 100 microns and 50 microns and even down to 25 microns, and obviously this is a casting material, so the mechanicals aren't that impressive, but the fact that you can go from a pattern to a metal part is where this material is really valuable. So we're excited to see what jewelry applications we can get into, or for small medical devices, as long as the cross sections aren't too thick. The coefficient of thermal expansion would allow you to cast these parts in various metals. Obviously, in the bottom up space, dental is an incredibly important segment, right? So here we're showing off our key guide material from Keystone. Keystone's been a great partner to us as well. This is a really cool material because it offers biocompatibility. It's strong, easy to polish. It could also be put into an autoclave, which is pretty unusual for photopolymers. It also passes the ISO 10993-5, 10993-10 regulatory body for biocompatibility. So really great material for drilling guides and cutting blocks, and also anatomical models as well. So definitely excited about that. And then as far as Key Model Ultra is concerned, this is a great material for clear aligner production, also for general dental models, ortho models, prosthodontic models. And we have also this other key ortho model, which was specifically designed for aligner manufacturing. I think both of them work well for aligner manufacturing, so it just depends on which color you prefer. We plan to continue expanding our material base, right? I think materials drive applications, and I think the group of companies that are investing real R&D dollars in developing new disruptive materials are the ones we just showed you, and plus these guys as well. And so we plan to work with each one of these companies to develop and bring the best materials to our customer base. Lastly, we are new to the market, right? So I wanted to just highlight the fact that we're very very pleased to have the beta customers listed on the screen. And these are typically, if you've been in additive for a while, you've probably heard of these companies. They're plagued. They have tons of dinosaurs in their companies, right? AMUG dinos all over the place, right? So these are not the easiest customers to appease. In fact, I think there's an argument to say they're probably the hardest customers on the planet. But they're incredibly knowledgeable, and they've been in a position to give us amazing feedback. So this is I just wanted to share these comments that they gave us, which after completing our beta program. By the way, each one of these companies did end up purchasing the beta unit, and we're continuing to work with them as well. So obviously, if you have a good relationship with Adman or Dinsmore or Midwest or MSOE, feel free to reach out to them if you're looking to get parts printed. All right, so at this point, I'll just say this. The Lumia X1 is coming to the US and Western Europe. If you think you have an application that could benefit from the combination of extremely high resolution, extremely high accuracy, amazing surface quality, and blazing speed as well, I really strongly encourage you to consider this machine. Reach out to us at Extra 3D. We'd love to take a look at your application and see how this new technology could push things forward. At this point, Gianni and I are ready to take some of your questions live. So without further ado, go ahead and put your questions in the chat, and we'll go ahead and answer those questions right away. Thank you so much for joining us. All right. Well, thank you for everybody for joining. I really appreciate that. Um, Gianni and I are here live to take your questions. I hope this was an informative webinar for you, especially for those that stayed all the way to the end. So thank you. Well, Gianni, it looks like we did a pretty good job. I'm not seeing any questions yet.
And also you, sir.
Use the sharing pane to show your screen. Don't be able to do that. Not seeing any questions here. If you have a question, just go ahead and type it in the chat, if possible. I think Sebastian has a question. Let me see if I can unmute. Okay, thank you, Sebastian. Okay, so Sebastian's question is, how is the process to remove the parts from the platform?
Paul, I'm assuming that you can easily write this question. So
I'm happy to take this one.
User experience.
Yeah, absolutely. So Sebastian, just like many other bottom-up technologies, we're adhering the parts directly to the build platform. So you usually, obviously depending on geometry, generally speaking, we recommend using a knife or some sort of a blade to basically wedge underneath the supports. Once you have a little bit of a space, they come off quite easily. Then of course, sometimes you can build directly on the platform, and in that case, you do the same exact thing. You just be careful not to hurt the bottom of the part.
But let me add something, Paul, maybe important. As you know, right now, Sebastian, of course, thank you so much again. Now we are also introducing a new completely flat platform where the user experience will be would be for sure easier now when you have to remove a part directly from a platform. Why, in general, on the whole platform, platform, reason why together Lumia has on board a double z-axis system. In general, you have to use an whole platform when the z-axis is not so strong, or when the viscosity of your material is not so low. Now, thanks to the new technology with the ceramic swimming pool, we will start speaking about also the 3-layer technology we have on board, one of our most important patents in our Lumia X1 and Revox X1. We will start speaking about 3-layer. You will see that now, thanks to the technology we have on board, we are able to work with ultra viscous materials and flat platform to compensate the hydraulic pressure. And this aspect will be extremely important because we will simplify for our customers now the removal experience. So this is another very good point. And as you know, right now we are testing and we are delivering flat platforms for our customers, and this is something important and new for Lumia X1 experience, user experience.
All right, next question is from a friend of the company, Andreas Tulash. Thank you for your question, Andreas. And the question is, what is the minimum wall thickness you can achieve?
Oh, well, so well, theoretically, in theory, is of course 55 microns, simply because our laser now the minimum spot size we can achieve is 55 microns. But this is absolutely related to the material that you will use. For example, with with materials like the spot A, the gray functional, or with materials like the Evonik, with an incredible, or for sure 3D systems with an incredible resolution, seriously, we can stay close to 100 microns layer thickness. In general, depends on the material, but more important, it's not only a matter of wall thickness, but also a matter of capacity, thanks to the HPS technology and the laser, to create minimum feature and holes in a block of material. You know very well, Paul, with very good materials able to compensate X and Y resolution in the best conditions without over curing in X and Y. You saw today with your eyes, we can achieve 200 microns hole in a block of resin. So in general, seriously depends on the material that you are using, but theoretically 55 microns is the right answer to the Andreas question. Thank you so much, Andreas.
Yep. Awesome. Okay, we have another question here from Darshan. Thank you for your question, Darshan. And the question is, could we adjust the number of contours while printing with the laser? If you'd like, I'm happy to take. Yeah, sure. So the answer is yes, and that's one of the features that we can fine tune. So depending on the application, you can go 1, 2, 3, 4. I don't think we go past 4 very often, just not necessary. But the answer is yes. You can definitely control how many contours.
Well, maybe, Paul, is important to remember that our platform now is a hybrid platform. Now, Axo 3D is characterizing in-house their materials. Why? Because you know very well the slicer together with the HPS is completely new, and the complexity is pretty high when you have to characterize the material. But of course, we have to also remember that our customers are absolutely able to define new parameters, and so what does mean also managing number of contours and blah 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 in general, which is the reason why we decide to work with 1, 2, 3, or 4 contours. Depends on also in this case on the resolution and X and Y of the resin. When the resolution when the trace from the laser is pretty correct, close to 55, 60 microns, in general, with a couple of contours, we can easily cover the entire surface now and compensate, of course, the aliasing effect, working, of course, with the right DLP offset. But in general, for example, with clear materials, it's better to increase the number of contours and work with 3 or 4 contours. But in general, we have to remember that our customers are absolutely free to adjust following their needs, to adjust the parameters of their resin they want to use.
All right, so we have a follow-on question, actually a couple follow-on questions from Sebastian. So in line with his first question about removing parts from the platform, the follow-on question is he wants to know if there's more of an industrial way to remove them or if this has to be done by hand. Um, so I would say today it's a hand process. We haven't added automation to the system. However, I would point out that generally speaking, the 3D printer manufacturers aren't the ones actually creating the automation. We would look to partner with a robotics company that has a lot more experience in that space. So I would say our system is certainly open to being used with robotics and automation. But right now we don't have a turnkey solution. And then Sebastian, by the way, asked one more question, which is, are the platforms spare parts? So platforms are, I would call them more of an accessory. When you purchase a printer, you end up with one full platform assembly. It's a bridge and the platform. We always recommend that you have at least two. So generally speaking, we always quote at least one additional one. That way you can have parts on the platform, remove it, and put a new tray into the machine. But they are available for sale if you'd like to add additional platforms.
This is also another very good point from Sebastian. Thank you so much again, Sebastian. As you know, Paul, right now we are also studying a new strategy and a new technology to simplify life and speed up now the productivity of our customer. So I think that at the end of this year or in Q1, we will also introduce a new interesting application, again, to simplify, but also to increase the stability to avoid problems regarding the spatula when now the risk is to break the parts when you remove the parts from the platform. But again, in the worst case in Q1 2024, we will also introduce a new feature for our customers, again, to increase the stability of the process and simplify their life. And yes, absolutely, Paul, you know very well the Sebastian, the SBP, and the entire leverage and the entire mechanism today studied and designed also for robotic arms. So in the future, we'll implement a solution like this one. Yes.
Absolutely. Awesome. Thank you for your question. Okay, the next question is from Alexander. And his question is, how are the parameters set for the different materials? Manually, or are they set automatically via the selection of the material?
Well, no, absolutely. So we have a extremely precise and accurate procedure to characterize in-house materials. In general, this is pretty known on the market. We are used to start from the DLP or the projector parameters to identify the real and the best power in time for every single layer, and not only a matter of attention, but also mechanical movements and mechanism behind the peeling process. When in general, well, Paul, you know very well, we are used to characterize under a digital profiler every single detail. So step by step, we are able to define every single parameter of both laser and DLP. And the third step in the HPS characterization is so the combination of both the LED sources together, defining number of contours, exactly what we said a few minutes ago, number of contours, the DLP offset. And again, also in our slicer, we are seriously speaking about a real DLP offset. Is not a shrinkage in all the directions. Is a real DLP offset to compensate the pixelization, no, and the overlap between the DLP and the laser. But no, in general, we have an internal, extremely accurate procedure to define every single parameter of our resins together with our HPS light engine.
So just to recap, it sounds like I would say that there are pre-existing build styles available to customers. They can just go ahead, start using the printer, hit print, not worry about it. We spent a lot of time internally developing these, so you can just get off to the races with your printer. But also on the flip side, you also have full control, which is nice. So hopefully the best of both worlds. All right, our next question is from Jason Lopes. Thank you for your question. And the question is, for extremely small parts, am I able to run in DLP to take advantage of thin wall?
Absolutely. Yeah, please, Paul.
I was going to say, yes, absolutely. In fact, maybe the laser is even better than DLP for thin walls. And depending on the application, you know, like for example, if you have a thin wall and you require clarity, you know, again, this printer, HPS with the HPS Light Engine, can be used in an SLA only mode, in a DLP only mode, or an HPS mode.
Yes.
So thank you for your question, Jason.
But also, for example, Jason, with resins without the right reactivity, for example, with a laser or with a DLP, you can easily choose to work with that specific material simply in a DLP mode or an SLA mode. So at the end of the story, Lumix One is 3 printers in one: an SLA printer, a DLP printer, and of course our HPS technology. In this moment, honestly, we are seeing, I have to be honest, in general, with high performance materials, for example, from 3D Systems or Evonica or Enkel, we are seeing a lot of advantages using the laser instead of only a DLP. But there is also another technical point extremely important. It's a matter of resolution, and it's a matter of contrast. In general, one of the biggest challenge in LCD and DLP world is the contrast. Why? Because black is not real black. So you are also curing, you know, the surface and the pixels, sending a black image. This is incredible, but this is real. And of course, when the job is so fast that you are preheating the resin. So in general, this is exactly the opposite with laser. And that's the reason why laser in general is more accurate, because the laser is light on, light off. So from in our experience, at least with the new portfolio of resins we are characterizing right now, the laser sounds better than DLP for minimal features.
Awesome. All right. Sounds like the next question is from John. And the question is, for flat platforms, will there be a release film or anything to make removal easier?
There is a surprise for the future.
Great question.
This is one of the surprise in Q4 2023 or Q1 24. Yes, exactly what we said a few minutes ago.
So coming soon.
Yes.
Okay. Thank you, Gianni. Okay, John also made another astute observation, which is, his question is, I noticed mostly rigid materials in the pipeline. Can you talk on any elastic materials in development? I can take this one. Yeah, so yes, you're correct. Actually, we think the Lumia X1 will do really well with elastomers, just because of the separation mechanism we're using. We're looking very closely at a couple interesting elastomers from in the BASF catalog at the moment, and we expect to have those added to our material offering in the next 3-4 months, roughly.
Yes, this is an important question. Theoretically, Paul, you know, we printed elastomers right now, but we are moving through with our portfolio development, but in the roadmap, of course, and maybe also in the near future, also a real silicon in our development. But this is a very good point. Also, in this case, thanks to the two-layer technology, you know, well, the peeling compensation in our case is so smooth that I'm pretty sure that we will achieve an incredible resolution, also printing pretty low shores. Like, you know, in our planning we have also 35 and 45 shores now. So together, I'm extremely confident that with the neutral layer technology, we will achieve an incredible results also in elastomer characterization.
Absolutely. So Darshan asked another question as well, and the question is, what about post-curing units? Do we have a standard post-curing unit through which materials are qualified on this printer? So So I'll start if you don't mind. So one of the challenges of having such a vast and diverse material portfolio is that not every single material requires the same thing. So so one of the things we're doing is we're developing our own post-processing unit. Now, we're not going to release a lot of details about it now, but this is designed to be kind of a super station, something that really addresses all the materials from a curing perspective and from a washing perspective. Between then and now, we're actually making one-off recommendations based on the material and the needs of each customer. So I don't know if you want to add to that.
Absolutely, very well said. Yes, we are working with a couple of very important manufacturing company in both Europe and US right now. And for sure, we will follow in the same style and the same approach we use for Lumia and Revox X1. Absolutely, first part of 2024, we will release on the market, and this is one of our priorities. I think an incredible postation, another industrial piece able to work with the entire portfolio of materials today on the market and maybe more. And well, Paul, you know very well, we are also working closely with at least 3 or 4 resins manufacturers to design a postation able to cover wild portfolio of materials. So absolutely, this is mandatory for our company at this stage. Yes.
Yep. Okay. We got time for a couple more questions here. So Jason Lopes, looking towards the future, if I have more than one machine, does the software also run as a query to my fleet, and is reporting on my builds available? I would say yes to both of those questions. You know, depending on, so fleet management will likely be done through a partner that we work with, and we're in the last stages of kind of solidifying those relationships now. But absolutely, we feel that data is critical to additive manufacturing scaling and to taking a more prominent role on the manufacturing floor. So we have plans to have all of those requirements in place. Great question.
Yes, and integrating the entire data collection and data management and flow management in our bridge between the printer and volume, together with fully integrated with our slicer and our workflow management. So absolutely yes.
And then Sebastian asked another question: is a list of materials and upcoming materials available? So Sebastian, the list of materials that we went over on this webinar are kind of the publicly announced materials. By the way, since we last spoke, Sebastian, I'll say kind of off the line, I think we have a new material that we'd like to share with you. So let's work with Andrea and show you what we have. I think we can also share our future roadmap with you as well, of course.
Of course.
Thank you for your participation, really. Jason, another question from Jason Lopes. If I was to explore third-party materials, does Extra AE help me to dial in based on parameters?
Absolutely.
Well, Jason, for you, of course. No, I'm just kidding. Yeah, for any customer, of course, we want to help our customers. You know, we have to take a look at the R&D investment that would be required from us and come up with some arrangement. But absolutely, we're here to help.
This is one of the services of our Extra Academy, capacity to design also in a sort of specific configuration, but also the materials we have right now. In remembering, Paul, now the question about number of contours, sometimes maybe different customer can have different needs, and so we are also able to adjust for them a specific characterization, not jumping from electrical connectors to molds. Now, you know, the applications sometimes are so different that maybe you have to adjust your parameters where the speed is more important than the resolution or surface quality or mechanical performance. So absolutely yes, absolutely yes. One of the services of our Extra Academy.
Yeah, absolutely. Okay, so we only got a couple more questions left, but I think we can get through them and then we can end this this broadcast. So we have this next question is from Alexander. Are there already distributors in Germany where the printer can be purchased? I would be interested if you can look at the printer there. So yes, we actually we have partnered with AM Ecos in Germany, and I'm happy to make an introduction here after the webinar. It'd be my pleasure. Okay, I think that's a wrap for now. Thank you very much for everyone for joining. I hope you found this informational, and we look forward to working with you in the future. Thank you.
Thank you so much.